Okay, our next presenters, Pierre, Vincent, and Julien. Pierre is the founder and CEO of Delair Labs. Pierre is an entrepreneur with 30 plus years of experience in cinema audio video presentation. He is the inventor of the revolutionary and patented front wave audio technology that emits front channel sound from the front of a non-perforated screen. Julien is a technical evangelist for Delair Labs. Julien has worked with many post-production studios and high-end movie theaters, educating the industry about the video fundamentals and best practices. He has also brought his expertise in design and calibration to post-production facilities, commercial movie theaters, screening rooms, and TV stations such as TSF and Canal+. Welcome.
All right.
Thank you.
Thank you for having us. All right, so I will go through just a brief history of the cinema sound. Then we'll go to the measurement we did with the methodology. We did that with some standard perforation screens or micro-perf screens as well. When we have identified the problems due to the perforations, we go to have a closer look to them. And then we'll talking about what we're doing in order to address that. Also, some of you have already been through this in the previous presentation, so I'll be quick with this. So first, of course, there was a jazz singer on the first talkies. In the 40s, it was decided to put the speaker behind the screen with a perforated screen. This is where the problems began. Then came the multi-channel sound with Fantasia, multi-channel sound. There were different layouts, but this is one the mostly used one. Cinerama, you have a bunch of channels, either in the front or in the back. The Rob was the first CinemaScope widescreen movie, but in addition to that, it was also a multi-channel one with surround sound and the LCR setup for the screen. Then a higher quality system with a 70mm was introduced. We could get 5 screen channels or 3 screen channels behind the screen, in addition to the surround mono sound. Thanks to Dolby, the surround sound soundtrack was made widespread in a way, because with the matrix encoding sound, we could get a center channel and a surround sound even in a 2-channel container. With Star Wars, we saw the birth of the LFE channel in order to have a bass reinforcement. And 40 years ago, there was the 5.1 through Apocalypse Now, and the 5.1 sound was with us for decades after this, especially with the advance of digital sound for either 70 or 75mm. We got first the CDS, Dolby Digital, DTS. In addition to those, there was Sony with a Sony Dynamic Digital Sound. This one was available in both 6-channel and 8-channel versions in order to accommodate the older 5-screen channel setup, while having both the LFE and the stereo sound. Then with the Star Wars, The Phantom Menace, we got 3 surround channels. It was matrixed in the surround channels in order to get a third one. It was so compatible with the existing 5.1 channels. And of course, we got rid of audio compression altogether thanks to digital cinema. The sound was stored in PCM. And while typically a digital cinema presentation was made in 5.1, Dolby introduced the 7.1 layout with 4 surround channels in order to accommodate the fact that in the residential market, it was the way it was with the advent of Blu-ray. And then we came to basically to get rid of the channel-based concept. It's the object-based audio. And basically, we can have an infinity of surround speakers. So why did we go through this? To address the fact that as years went by, we saw the multiplication of surround speakers, but the majority of the sound still comes through the screen. And the problems typically addressed with screen perforation I'll never be addressed. So what we did, we took some sort of measurements in order to quantify the problems. What are the consequences for the audience? We did this in the screening room located in Paris, TSF. Basically, we take measurements without the screen, and we did this at the sweet spot on the axis. On the side, we did the same thing with standard perforations. We did the same thing with microperfs, because microperforations have been more and more used because of digital cinema, 4K, and laser projection. And when we saw what was happening, we took a closer look to the phenomenon. So this is the point of measurement. This picture was taken from behind the screen, obviously. Maybe, no, you can't tell from it, but on the picture you can see the tiny holes. And what you got, the green line basically is a measurement without any screen which would get in the way. And with the red line, of course, it is the consequences of the use of perforations on the screen. So we can see that the problems start to arise even if we are on axis starting at 2K. Then if we go on the side, obviously since we are not right in front but located at more than 45 degrees, you can see the problems arising even more sooner, almost starting at 500. Again, we went on axis. This is actually the sweet spot. We can see the differences of amplitude due to the phenomena of the screens. Same thing off axis. You can see, again, it starts sooner. On the axis, it starts slightly below 2K. On the back row on the side, it's almost the same, because the further we go from the screen, of course, the lower is the angle. So the conclusion, of course, the coverage is affected. The sound quality by itself is affected, especially starting from 2K. It starts even lower the more we go off axis. And the phenomena for you are well known. It is the standing wave, or it is called as well the filtering effect. Basically, we did the very same thing with another set of perforation size. What we will see, it's basically the same thing, but it will go from 500 hertz. So the problems start sooner compared to bigger perforations. Same thing off axis. So you can see the problem started even sooner. Same thing here. Same thing here. And basically, the smaller the holes, the sooner the problem arises. So we have about the same conclusion that the last set of measurements, except that it's starting ever sooner and the problems are even worse. It should be noted that with digital cinema and laser projection, we have a tendency to use those type of screens as opposed to the traditional ones. So now we have seen where the problems. Let's take a closer look. We make measurements quite closer to the screen, and we made some variations. We decided to try what would happen if we basically take the measurement on and off axis from 0 degree to 60 degree by steps of 5 degrees. We tried to tilt the speaker, because typically in a movie theater, you know, the speakers are tilted in order to be aimed to the audience. And we tried another thing, is to make vary the distance between the speaker on the screen, very, very tiny steps. So for the angle comparison, it's basically obvious. There is, of course, the roll-off. The more you go off axis, of course, the less sound, the less FPL you get in the highest frequencies. So this is nothing basically new in that regard, but you can see what's happening. Of course, it would depend on the directivity of the high frequency drivers. So this is the same thing in 3D, basically. On the x-axis, you get the frequency. On the y-axis, you get the angle. And on the third axis, in colors, you get the FPL. Donc, as we could see, basically, yes, it is. You can see the roll-off here, more symbolized, in the corner. Now, with the screen, what is happening? Yes, it's, well, shall we say it's a mess, really, compared to the regular roll-off, we can see. And we did the thing on 3D. The thing was what is happening. Again, you have the x-axis is the frequency, the y-axis is the angle, and of course the third axis is the SPL. So it's less regular. It's there, you get more accident. So this is the conclusions. Of course, as I said, it is the consequences of the standing wave or the comb filtering effect. The fact that you have accidents, especially in amplitudes, this is what makes what we call the bright and aggressive sound. Of course, the further you go from the axis, the worse it's become. And of course, no amount of EQ can address that for every member of the audience. The other thing that we tried, so we did tilt the speakers slightly this way and to see what would be happening. There is no, of course, we do have the accident in amplitude that I was talking to you about, but tilting the speaker won't do that much. It's very slight variation, nothing big. We went from 0 to 8 degrees. Okay, but so we try to address the problem that way, but it won't change much of the problems. More interestingly, we did the variation of the distance between the screen and the speaker, very small steps. And what we found, it's basically the same phenomenon would occur, but only the frequency. Oops. Okay, so basically, this is the same phenomenon occurring, but as we move the speaker, the frequency changes. We can illustrate the fact that the phenomenon is the same, but the frequency only changes. Yes. This is every distance put together. You can see the problem due to the screen perforations. And this is the 3D representation. The distance, the SPL. So we can see there what is happening. Basically, as we shift the speaker, there is a shift in frequency as well. So for the conclusion of these findings, the screen, of course, amplifies some frequencies and not the others. Of course, as I said, the aggressive sound and the bright sound is a consequence of the accidents you can see in amplitude. The EQ might solve some of the problem for members of the audience who are located on the axis, but of course, the same EQ won't address the problem for the members of the audience who have the misfortune of being on the sides and not the sweet spot. It can be even worse for them if you want to EQ something. It worsens the problem in a way. So, as I said, it should be noted that this phenomenon, when we have the distance varying, it's not just about choosing the right distance between the speaker and the screen, because when you play a sound during the movie, the screen have a tendency to move itself. You know, with if you have a high SPL, the screen will move. So even if you do good tilting, a good distance, and a good EQ, even if it only concerns the people located on the axis, if I can go back, here we go. Sorry, Linda. This is what will occur during the playback of the movie, even if everything was set for a given distance and angle, because the screen would be moving during the movie playback. As I said, we did this very, very tiny amount of variation. So no EQ can address this at all, and you can anticipate the fact that the screen will be moving anyway during the movie playback. So this is what we're going to do in 3D. So what we are proposing is a system with different types of driver for different types of frequency ranges. As you may have known, we are, for the purpose of this presentation, we only did the high frequencies because it would have been a bunch of data to address. But basically, for the frequency above 5K, you are using small satellites to address the high frequencies. After, between 700 and 5K, we have a very specific set of flat transducers. Basically, they are almost glued to the screen. On below 500, we are using a more traditional type of speaker. So as I said, basically, this is the first part in the series of white papers we are doing. But that's why we concentrate on the high frequencies. And basically, by having the frequencies above 5K not behind the screen, we are addressing all the problems we quantified at least above those frequencies. After the transducers, they do address those problems, but in another manner. Oh, thank you. Okay. So Pierre will be with me to answer some questions. Yeah.
Any questions from the audience? Here we go.
I know that one of the name is Roddy, Vincent. One of the decisions of going between micro perf or small perf and cinema perf is, can you see them from the distance in which you're sitting from the screen?
Yes.
So.
Yes, and some people who went to another event saw the consequences of the light output with the perforations. Because the brighter is the picture, the more obvious the perforations will be. Yeah.
Merrill Weiss Group. Two questions, really, in somewhat different areas. The characteristics you were showing looked awfully a lot like filter technology. And I wonder if you've characterized the filter characteristics or thought about it in terms of filter characteristics like low-pass filters or echo filters that cause echoes as a way of analyzing the results you were getting. That was one. And the other is, what happens when you have height speakers involved?
Height speakers?
When you have speakers that are for immersive sound, where you have speakers at different levels in order to give you different directivity.
Oh yes, I see what you mean. Pierre, t'as compris ce que je veux dire? I think to answer your first question we did the other measurements, basically at near field. So I don't know if that answers your question about the filtering. Were you asking me about the fact that the room would affect the measurement we did? I'm not sure if...
I'm sorry, not getting your question back to me, I guess.
Okay, so the second question was about the height speaker. The height speaker. We did some experiments with Dolby Atmos setup. as well. So the whole idea is to get better transition between the sound from the front of the back on the ceiling. I don't know if that answers your question. Are you asking us if the directivity of the 8 speakers were different with what we get from behind the screen?
No, the question was, since you're putting your high-frequency speakers above the screen.
Oh, I see, yes.
What happens when you want to have directivity that points above the screen?
Oh, yes, t'as compris la question, Pierre? Qu'est-ce qui se passe sur les enceintes au-dessus de l'écran en plus du satellite qui est en haut?
Je suis pas sûr, non,
Hein?
c'est pas ça la question.
Si, la question c'est que s'il y a des enceintes au plafond au-dessus de l'enceinte déjà pour des 8 speakers comme en IMAX, qu'est-ce qui se passe à cause du satellite qui est déjà en haut?
Ça change rien. Hein.
Non.
Ouais.
Non, il dit quelle est la directivité, est-ce que du coup on peut différencier les deux?
Oui.
Yes, we can differentiate the both of that because yes, we can differentiate the sound from the 8 speakers to the screen channels because below 5K you can tell it's not from the same directions. We have yet to test this in an IMAX configuration. It might work, but we have yet to try it. All I can say, if we tried with the Dolby Atmos setup, with speakers on the ceiling, not far from the top of the screen, and we did not experience any problem in that regard.
Hi, Brian Bessis from Sony Pictures.
Brian.
So I understand Meryl's question, and I've had the same question. Actually, I'm going to amplify on his, and then I have my own question. So when attempting to simulate a location from behind the screen, and we're putting speakers outside the screen to try to do that, and we're playing some games to try to get you to, I believe it's coming from the screen. When we have actual height information that's being intended to be height information, whether it be from an Atmos system or maybe some other system that's got speakers high and up on the ceiling, I think the mind could be potentially confused between what's intended to be height information and the height information that's actually coming from speakers that are above the screen. So I think that that's what Meryl's question is about. And I think that that would be a fairly serious issue myself. The issue that I was going to mention, and I'm not sure it's an issue, but to me, I didn't get much out of your presentation about localization of sound and stuff like that. I saw the curves, and I've done studies myself about what happens when you put speakers behind screens and how you get the reflection back, and it's sort of pretty much been proven you can't hear that very well once you get away from the screen, but we do know that it happens. But I'm really trying to maybe get from you why you're convinced that we can, because of the curves you showed us, that our minds are going to be easily convinced that we're hearing sound from the screen when we're not.
Yes, but
because I didn't see any of that in your slides. I didn't see any of that localization type of discussion, which I think is a big part of it. I mean, it's the huge challenge, of course, that we're having with the direct view displays. We can't put speakers behind the screen.
Of course, yes.
And there's a number of people trying to find solutions to that. And you know, we have a lab where we're trying to find solutions to it too. But could you maybe elaborate a little bit on your thoughts on that, either from your slides or just in general?
Yes, I see what you mean. Of course, if you compare to new technology using flat screen, obviously the speakers are above, around. Of course, it looks like similar, but it's only for the very high frequencies. So basically, your brain can basically add the whole thing since the flat transducers and the more traditional woofers, they are at the right place. Basically, you have to listen to the system to really understand this. But basically, the brain is doing some work itself. But of course, it is a better solution to have the totality of the frequencies, coming from around the screens. I don't know if that answers your
Okay,
question.
but I'm really not referring so much to frequency response as I am about localization, right? Aural localization, where we perceive a sound to be coming from. And of course, the challenge with the direct view displays is to convince you that you're hearing it coming from the screen, which you're not. So did you have anything in your presentation about that? Because that's sort of what I thought we were going to hear about when I read the synopsis.
Yes,
Vas-y, vas-y, t'as le micro. Hein.
yes. Actually, your brain localizes sound with the fundamentals and not with the very high frequencies, who are harmonics. So the best way is to come to see us at Hollywood. We have made a setup, so you can experiment it and see how does it work, because yes, it's about perception, sound perception with the brain, and of course there's a big influence about the image. When you see a movie, the sound you will hear will be very influenced by the image.
Yes, the brain does a lot of work
Yeah.
in that regard.
So you're just saying that because we see the image where it is, your mind will bring the sound to where the image is?
In part, of course, it won't work
Yes.
with with the full frequency
Yeah.
setup. But since some of the sound comes from the right place, only c'est les harmoniques et photomontales qui sont là-haut.
Oui.
So
Harmonics.
so only harmonics are concerned by satellites. It can do the trick. Yes.
All right, well, thank you.
You're welcome.
Hi, Tom Scott, retired. One of the puzzles in this kind of solution, and I think in the literature going back even as long as probably 15, 20 years, this problem has been examined from a number of points of view.
Yes.
And the
Yes.
sad thing is we haven't found anything better so far than the perforated screen, and the improvements that different types of perforations, woven, et cetera, have come up with. But the big problem that I think Brian was trying to get at is the directionality is not the only thing that might be impacted by having these multiple sources. Could you say a few words about the types of crossovers? Did you imagine that you would use a standard crossover to crossover from the low frequencies to the highs? And if so, what kind of curves would you use? And the problem that I would anticipate is one that we've run across in music recording long before, with no perforated screens, is any distance between the high frequency and the low frequency, or the mid frequency and the high frequency. You may remember in the literature there was a great deal of time spent a few years ago on time alignment, and the fact is the distances are filters themselves, and the area of the crossover is going to be a really nasty physical filter, because the high frequencies are coming from several feet away from the same frequencies. The lowest of the high frequencies and the highest of the low frequencies are going to be coming from separate points.
Yes.
And as you try and move around in the audience, it's a nasty physical filter. And I wondered if you guys had thought about this. And the last point, I wondered in your experiments, had you worked with any sort of sound absorbing material on the front of the loudspeakers to cut down the reflections and
Yes.
see how that might happen?
Well, you're not the first one to ask this question. It is a very fair question about.
Yes, there's a big difference because between the IR filters and FIR filters. I don't know if you know about these two different technologies. And now we are using FIR filters, so we can do a perfect time alignment for all the room. So yes. Basically, we address this problem.
Okay, any additional questions? Okay, great. Thank you, gentlemen.
Thank you very much.